uh, like what that sorry. So you have I to some power. In that power, you look at what its remainder is when you divide it by 4, and then you just compare it to these base 4 these base 4 numbers, and then you can just like equate the two, right? So as an example, we can try to figure out like I to the 40th power, and then we can realize that 40 divided by 4 has a remainder of 0, right? Another way we could say that is 40 is 0 mod 4. And then we can just compare that directly with I to the 0th power, because 0 is also 0 mod 4, or when divided by 4 has a remainder of 0, right? So then we can say I to the 40 is just equal to I to the 0. And I to the 0 is just equal to 1, right? Anything to the 0th power is just 1. Um, so, so does that make sense? Does how the
Um,
pattern work make sense?
yeah, that
Okay.
makes sense.
So, so yeah, do you know now how to solve the I to the 49th power?
Um, maybe, I think so. Um, so, would it be, negative I?
Uh, you're close, but not quite. So we want to figure out what remainder 49 has when divided by 4, right? Another way of saying that is again
Oh, yeah.
3 mod 4, right? Or sorry, not sorry. We're looking for what mod 4 49 is, right? Um, and then so you can look at like the closest multiple of 4 to it, which is like 48, right? 48 is multiple of 4. And then if you increase 48 by 1, then you have 49, right? So that means 49 has a remainder of 1 when divided by 4, right? Does that make sense?
Yeah.
Okay, and then so then what would I to the 49 be?
Um, I?
Yeah, good job. Um, that's just equal to I. So it has a remainder of 1 when divided by 4, so then you can just compare that to I to the first power. Okay, so that's just like a little bit of the basics of imaginary numbers. It's just we're just looking at uh, the powers of just I. But um, imaginary numbers, like you can go like way deeper into it, and there's like a lot more of it. But just knowing this stuff for now is probably good. And then why we were talking with imaginary numbers in the first place was that like sometimes you get imaginary solutions to your quadratic equations. So how that works is like, let's say I have, let's just say I have like x squared plus x plus 1 is equal to 0, right? Um, Now first, do you remember the quadratic formula?
Um, yeah, I think so.
Okay, what is it?
Okay, negative b, um, plus minus, um, square root of, b squared, minus 4 times a times c divided by 2a.
Yeah, good job. So, so yeah, this is what x is equal to, right? Yeah, again, this is like a really important formula to remember. So good job that you remember it. But make sure that uh, you just don't forget it, right? Okay,
Okay.
so So let's say we have this equation here, right? X squared plus x plus 1 is equal to 0. So let's just solve for what x is equal to. So b is going to be 1, so we're going to have negative 1 plus or minus square root of b squared is going to be 1. Now a and c are both 1, right? So 4 times 1 is just 4, so we're still going to have minus 4. And we're going to have over 2a. A is just 1, so we're going to have over 2, right? And then, we can simplify the radical a little bit. We're going to have square root of negative 3 over 2. So here you can see that we have square root of a negative number, right? And again, square root of a negative number, it has no real solution, right? Square root of negative 3, it's not going to be a negative number and it's not going to be a positive number, right? So square root of negative 3 is going to be like an imaginary number. So if you ever have like square root of a negative number, it's going to be like imaginary. And you can simplify this a little bit by putting it like in terms of I. So how you do that is basically you just like take out the negative 1 and then you take out the negative 1 from the square root and then you just put that into I. And then you have the same square root of negative 3. So how that can look is like, so first we have like, we can separate this into negative 1 times 3, right? So this is still square root of negative 3. And then by, exponent properties, the square root is just like a raising to the 1/2. We can, have this, oops. So we're gonna have negative 1 plus or minus. We can have the square root on each number individually now, right? So again, the radical is just like an exponent, right, of 1/2. So we can treat the radical as if it were like this, all this to the 1/2 power. And then exponent properties, if you have like ab to the c power, you can also say that this is a to the c power times b to the c power, right? So yeah, that's basically what we're doing here. So we're putting the radicals on each of the numbers separately. And then square root of negative 1, we said that was a special variable, right? We set that to I. So we can say that the square root of negative 1 is I. And then we have negative 1 plus or minus square root of 3 times I over 2. So do all those steps make sense so far?
Yeah.
Okay, cool. So yeah, so then basically our solutions of x is going to be negative 1 plus or minus square root of 3 times I over 2. And this solution is imaginary, right? So basically, we still have two solutions of x, right? But those solutions are both going to be imaginary numbers, right? Both those solutions are going to have I in them. And what that means is that it's just going to be like a different number than the real number. So it's not like a positive number. It's not like a negative number, but it's going to be an imaginary number. But yeah, so you don't have to know like too much about that, but you just have to realize that sometimes you can get imaginary solutions with quadratic equations. And sometimes they'll ask you like, they'll give you this, let's just say they give you this quadratic equation, right? And then they're going to ask you something like, how many real solutions does this quadratic equation have? So one way you can solve that is you can do the whole quadratic formula, and then we get this, right? Negative 1 plus or minus square root of 3 times I over 2. And then you can see both solutions are imaginary, right? And they were asking how many real solutions does it have? So if both solutions are imaginary, then this equation is not going to have any real solutions, right? So then your answer would be 0. So does all that make sense so far?
Yeah.
Okay. And you can also, so you're just going to show just a little bit more about this, and then we'll move on. Oh, also, anything you want to say, Bill?
Uh, no, I'm good. Uh, yeah.
Okay, so now let's move on to the sixth slide. So I'm gonna write the quadratic equation again. So is x is equal to negative b plus or minus the square root of b squared minus 4ac d2a. So there's like a little bit of faster way of how we can tell like how many real solutions that a quadratic equation has. Like all we have to look at is just this term here, square root of b squared minus 4ac, right? Because this is the only thing that has a square root on it, and it's the only thing that's going to determine like if we're going to have like imaginary solutions of x or if we're going to have real solutions of x, right? So what we have to look at this term is square root b squared minus 4ac. And how it's going to work is, if b squared minus 4ac is negative, then we're going to have square root of a negative number, right? So then our solutions are going to be imaginary. But if b squared minus 4ac is going to be positive, then we're going to have square root of a positive number, and that's just going to be a real number, right? So does that kind of make sense?
Yeah.
So yeah, so basically like um, so we can start with um, just any quadratic equation. Let's say we have the same thing again, x squared plus x plus 1 equals 0. If you just wanted to find like how many real solutions does this quadratic equation have, you can just do this and solve it like a little bit faster than if you like go through the whole quadratic equation, right? So I can look at what b squared minus 4ac is. So b is going to be 1, right? So b squared is 1, and a and c are 1, so we're just going to have minus 4. So then b squared minus 4ac is going to be equal to negative 3, right? And then because it's a negative number, we're going to have two imaginary solutions, right? Because we're going to have square root of a negative number that's going to be imaginary. All of our solutions are imaginary. But if we have a different equation, like let's say we had x squared plus 3x plus 1 is equal to 0, and we just want to find how many real solutions does this have, we can just quickly find what b squared minus 4ac is. So here in this case, it would be 9 minus 4 is equal to 5, right? 5 is a positive number, so that means we're gonna have in our actual equation we would have square root of a positive number, right? And that's real. So that means both our solutions are gonna be real, right? And there's a special name for this term actually, b squared minus 4ac. It's called the discriminant. Kind of a big word, but yeah. I can also spell it out. It's called discriminant. Um, Now the name of this, I wouldn't say it's too important,
I mean,
because it's just names. But
sometimes
like,
they'll ask specifically to
yeah,
find the determinant, so
discriminant.
discriminant. Yeah,
Yeah, I
my
don't
bad.
know. Like, it's not like if you can't memorize the name right now, it's not too big of a deal.
Yeah.
Um,
Okay.
you could, yeah, just notice that it's called that, and if you forget it, it's fine. But like you'll encounter it again later. Um, and yeah, some math competitions or just some stuff might just ask you for the discriminant. So it's kind of important, but I feel like right now you don't necessarily have to know the name. But yeah, okay. So basically, yeah, to see how many real solutions a quadratic equation has, you can just look at the discriminant, which is b squared minus 4ac. If it's negative, you're gonna have two imaginary solutions, right? And then if it's positive, you're gonna have two real solutions, right? But there's one other case that you can have, right? Um, which is if the discriminant is equal to 0, right? So like let's say I had x squared plus 2x plus 1 is equal to 0, right? So in this case, okay, so we're looking for the discriminant. In this case, b squared would be 4, and then a and c are both 1, so we still have -1. Then we see that the discriminant is equal to 0, right? And then if you think about what happens when the discriminant is equal to 0, um, we're going to have like x is equal to -b plus or minus the square root of 0, right, over 2a. And then square root of 0, um, it's always just going to equal 0, right? And like, if you have plus or minus 0, um, that's not going to change anything, right? Like plus 0 is the same thing. Minus 0, like plus 0 doesn't do anything. Minus 0 also doesn't do anything, right? So essentially we could just cancel this out, right? And then we have x is equal to just -b over 2a. And then here we only have one solution for x, right? So basically, if your discriminant is 0, then you're only going to have one real solution of x. Does that make sense?
Yes.
Okay. So yeah, so if you're asked to find the number of real solutions for a quadratic equation, you can check what the discriminant is. And specifically, you check if it's positive, 0, or negative, right? If it's positive, you're going to have two real solutions of x. If it's 0, you're going to have one real solution of x. And if it's negative, you're going to have no real solutions of x, right? But keep in mind, if it's negative and you don't have any real solutions, you still have two imaginary solutions, right? Okay, so do you have any questions so far?
Um. No.
Okay. I feel like this is a good place to stop. What do you think, Phil?
Yeah, I think we covered pretty much everything with quadratic stuff.
Well,
At least like
you,
the
you,
stuff we need right now.
yeah, right now. But like, I don't know. Graphing is probably also important, right?
I guess.
Yeah,
Yeah, we could do
like,
graphing.
uh, I think we should just look at the problems now. And
Okay, yeah.
if we come across graphing, we can
Yeah.
just do it. Also, again, this is just like regular curriculum that you see in like Algebra 1, Algebra 2. So, um, so yeah, you can also just like learn this stuff by yourself, um, from like Khan Academy or something, or like just textbooks. So, um, this is stuff teach like in the curriculums, Uh, so we can look. So I think we had a Jamboard for some chapter problems. Uh, okay, so actually we have this Jamboard, and we just have um
One question?
one problem left. Yeah,
Oh,
but
okay.
actually like all the slides are taken, so I'm just gonna
You can delete a slide probably.
or I'm just gonna uh
Alright.
paste some to this Jamboard if I can. Uh, you see, like, why can't I copy the image? I actually can't copy the image. Hold on.
You can't just control C, control V.
Yeah, no. I'm gonna
Which one is
take a
it?
screenshot of it. I'm
Okay.
taking a screenshot of it
Or C.
real quick. Okay, I put it on slide 7. So, so yeah, this is 2017 chapter sprint number 20. So we were looking at this like a while ago, and we already did like all problems like 1 through 19. So we're looking at this problem, and then it's a quadratic equation problem. So then we got into all the quadratic equation stuff. Um, Now we can look back to it. So what is the sum of the solutions of x squared plus 5x plus 6 is equal to 0? Um, so do you want to try out this problem for yourself first?
But I have a question. For a problem like this, would I use the quadratic formula?
You could,
You could. You could.
but
This
there are
is
also
also.
other ways to solve it, like factoring.
This
Do
is
you
yeah.
remember that? You
This is also
can also solve this
doable
by
by
factoring.
factor.
Oh
Um,
yeah. Okay. Um, I am I kind of had trouble on it. Like I had trouble solving it.
okay. So first, do you like realize what we're trying to solve right here?
Um, uh,
So like we're trying to solve for what x is, right? So
yeah.
And it says, like when it asks about the solutions, it's just asking about solutions of x, right, to satisfy the equation. And then it just wants to know what the sum of those possible x solutions are, right? So if you have a quadratic equation and you want to solve for x, so far you've learned like two ways to do it, right? So you have quadratic formula or factoring. So first, like, which one do you want to use here?
Factoring.
Okay. So factoring, so like we said before, if you have this equation and the x squared term has a 1 coefficient on it, so essentially like a is equal to 1, then you have when you factor it, you can just start with like just two x's like that, right? And now all you're trying to figure out is like these two numbers, right? So we're gonna have plus something and plus something. We need these two numbers so that when they multiply together, it gives 6. And when they sum together, they give 5, right? So, you know, we get the 6 by multiplying these two together, they're both constants. And then we get the x term by multiplying each constant with the other x, right? Like they're both 1x. So, um, they're both going to be like weighted the same. So essentially, it's just going to be the sum of these two numbers has to equal 5, right? So like, another way you can see this is just putting this with variables, right? So a times b is going to have to equal 6.
Oh, okay.
Uh, and then you have like ax plus bx has to equal 5x. You can just take out an x out of all of these, and then you have a plus. Um, and then you have these two equations. You can just solve them in your head, essentially. So you need to find two numbers that multiply to 6 and the same numbers that add up to 5.
Okay. It's 2 and 3.
Yeah.
So,
So then we can factor this equation into x plus 2 times x plus 3, right? So if we multiply this out, we will get exactly x squared plus 5x plus 6, right? So we can say that this is equal to 0, right? Because our original thing was equal to 0. And then um, and then do you know where to go from here?
um, yeah, I think so.
So what would you do?
You would, multiply, x times x, and then x plus x times 3, I think. And, uh,
So like what you're doing there is you're re-expanding um, you're re-expanding this, right? You
yeah.
wanted to multiply this back, but like if you re-expand it, you're just gonna get uh, the same equation that you started with, right?
Oh, yeah, sorry.
Again, our goal is here is to solve for x, right?
Okay, I'm not sure.
Okay, so the point of factoring is to get into a situation that looks like this, right? And we can solve for x just with this, right? So like we have two numbers that are multiplying and it equals 0. Um, so then what, do you know what that like tells us?
Um, it has to be negative.
Or what has to be negative?
Um, X, I think. I mean,
So like first let's just think about like being multiplied together, right? So like we have a times b. Um, and let's say equals 0, right? So does that like tell you anything about the numbers a and b?
oh, yeah, one of them has to be 0.
Yeah, one of them has to be 0, right? Like either or, right? Either one of them is equal to 0 or both of them are equal to 0, right? So we can use that same technique here to basically like solve for x. So, we can treat x plus 2 like it was a, and x plus 3 like it was b, right? So we can say x plus 2 has to equal 0, or x plus 3 has to equal 0, right? Does that make sense?
Yeah.
Okay. So then we can just solve for these two equations individually, right? And then you can see the equations that we have now are both linear equations. So you can just directly solve for x. So on the left equation, we're going to have x is equal to negative 2, or x is going to equal to negative 3, right? So then, then you can just say, like this is your answer, or x is equal to like the set of negative 2, negative 3. And then also, like I said, if you have two numbers multiplying to be 0, you can have one of them equaling to 0, or you can have both of them equaling to 0, right? But we can't have both of these numbers equaling to 0 in this case, right? Because like the solutions that we solve for are like x is equal to negative 2 and x is equal to negative 3. So you're saying both of them are equal to 0, then you're saying that x has to equal negative 2 and negative 3 at the same time, right? Which is impossible. So then you don't have to include that case, and then you can just say, x is equal to negative 2 or x is equal to negative 3. And, whenever you're solving quadratic equations, um, you never have to include that case, right? Because, um, if you get two different values of x, they're never going to be equal to each other, right? But it's like, so you never really have to think about that, but it's just like, I don't know, it's just like, it, it's just a small thing that can come into impact in like different problems, and it's just like a small thing to notice. But yeah. Um, okay, but so the question that we have here. So we wanted to find the solutions of x, and then we need to find what the sum is, right? So here we have our solutions, negative 2 or negative 3, right? So then you just need to find the sum of them. So can you tell me what the answer is to this problem?
Um, okay. So I'm a little confused. It says x equals -2 and -3, so would I just like substitute -2 with x for the first one, and then try it with -3, because
So you're saying substitute the x back into the equation, but like what are you trying to achieve with that?
um like, I mean, when you say some of the solutions, like, I don't understand.
What solutions mean?
Yeah, in this case.
Okay, so solutions, it's basically just asking you to solve for what x is, right? So it's like, like if you have solutions of an equation and then, it has like some x terms in it, usually it's talking about like, you want to find what x can be equal to in the equation such that it satisfies the equation, right?
Okay, so it would be, um, it would just be -2 and -3.
Well, those are the individual solutions for x, right? But it wants you to find the sum of those solutions.
Um, okay.
So like, so like we've already solved for those solutions, right? We solved that x is equal to -2 or x is equal to -3. These two numbers are my solutions to the equation, right?
Oh,
-2 and -3.
so would I just have to add -2 and -3 together?
Yeah,
Oh, okay. Thought it was more complicated than that. Okay, so it's just -5?
yeah, it's just -5.
Okay. Sorry, I was
Uh,
confused.
no, it's okay. So, yeah, if a question has like an equation and it's asking for solutions, it's gonna be talking about like essentially what x is, right? And then if it asks for the sum, then you're gonna want to find, it's kind of saying that you're gonna have like multiple solutions to x, and then you just need to add all of them together. Does that make sense?
Yeah.
Okay. Um, let's also solve this with a quadratic equation just to get a feel of it. So, we can do that on the 8th side. So I'm just gonna copy that same equation. Uh, x, okay, x squared. Okay, x squared plus 5x plus 6. So, let's say we're solving this by the quadratic equation. So we're gonna start with the quadratic equation, right? X is equal to -b plus or minus square root of b squared minus 4c over 2a. Now all you need to do is, um, you have your b, a, and c. You just need to plug it into the equation, right? So here we have a is equal to 1, b is equal to 5, and c is equal to 6. Does that make sense?
Yeah.
Okay. And then we just need to plug it into here, right? So we're gonna have -5 plus or minus, so 5 squared is 25. Um, a times c is 1 times 6, which is 6, and then 4 times 6 is gonna be 24, right? So we're gonna have minus 24, and then a is 1, so 2 times a is just gonna be 2. And then inside the radical, 25 minus 24 is just 1, right? So we have negative 5 plus or minus the square root of 1 over 2. And then the square root of 1, can you tell me what that is?
Um, 1, I guess.
Yeah, it's just 1, right?
Yeah.
1 times 1 is just 1. So then we just have negative 5 plus or minus 1 over 2. And then to get your two solutions of x, you just look at the plus and minus separately, right? So my first solution of x, I can look at the plus case. So I can say x is equal to negative 5 plus 1 over 2. So negative 5 plus 1 is negative 4, right? Negative 4 over 2 is just going to be equal to negative 2. And then my second case of x, my second solution, I'm going to look at the negative case. So here I'm going to have negative 5 minus 1 over 2. And then that's going to be negative 6 over 2. And then that's negative 3. So does that make sense? So we got the same solutions, right? We got x is equal to negative 2 and x is equal to negative 3. Then you just need to sum that together and it's still negative 5.
Yeah, that makes sense.
Okay.
Something else is like, for a question like this, where it's asking for like the sum of the solutions, if you think about it, if you add up the plus or minus, the things that you're plusing or minus, are like that they cancel each other out, right?
Yeah.
Yeah, so you kind of just end up with like negative. Whoa. So like you end
Yeah,
up with
so
negative 5 over 2, and then kind of just plus negative 5 over 2, since like this part, when you add both of them together, they cancel each other out.
like you can see
So you end
like
up with
you're
negative.
adding this and you're adding this, right? And then this part and this part will always cancel out
Yeah.
because
Oh.
you have plus and minus always.
So
I
sometimes you
mean,
won't have a nice number under the square root, so you don't have to always like solve out like the square root.
yeah. So sometimes you can get like square root of 23 or something like that, right? And then it's not like an integer number. Um, but if it's asking for the sum, it's still an integer, right? Because when you add it together, the plus and minus is going to cancel this out. So yeah, then it's just negative 5 over 2 plus negative 5 over 2.
Oh, okay.
Um, yeah, I mean, that's just a little thing. But yeah, okay. Um, Bill, do you think we should do one more problem or just end here?
We could probably do one more problem.
Okay, so let's move on to a different Jamboard. So this one is gonna have, wait, hold on. Um, okay, so I sent the link to it in the chat. So this one has the rest of the problems for sprint of 2017. So it's 21 to 30. Okay, so let's start with number 21. What is the quotient when 1000 is divided by 2q times 5 squared? So do you want to have a try this one yourself first?
Yeah. Um, is it, 5?
Yeah, it's gonna be 5. So how did you figure that out?
2 cubed times 5 squared is, 200, and it has 2 zeros on the end, and 1000 has 3, so I canceled out 2 zeros from both of them, and then 10 divided by 2 is 5.
Yeah, that's one way to do it. It's totally valid. Another way you can do this is also just prime factorizing 1000, right? So, you just start with 1000, and then, you can separate this into like two 500, and then two 250, and then two 125, and then, 125 is just going to be like 5 cube, right? I mean, you can also see this just by like, 1000 is equal to 10 cube, and then 10 is just 2 times 5, right? And then exponent properties is just uh, 2 cube times 5 cube. And then, so 1002 cubed times 5 cubed, and then if you divide this by 2 cubed times 5 squared, then the two cubes cancel out, and then two fives will cancel out from the top, so then you just have 5. That's your answer. So that's just what you do.
Okay.
Okay. Um, okay, it's for the quad, so I think we can just stop there. I thank you for coming to our meeting, and we'll see you next time.
Okay. Thank you. Bye.
Bye.